Okay, so very good afternoon to all. I welcome you all for this lecture of industrial hydraulics and pneumatic subject. Okay, so yesterday we have discussed about the linear actuators. Okay, and in that we have seen the definition of the linear actuator. Then we have gone for the designation of the hydraulic cylinder. Okay, then basic construction and operation of the hydraulic cylinder, that also we have seen. Getting it? And after that, in detail, we have gone for the hydraulic cylinder classification, types of the hydraulic cylinders. Okay, and after that we have started single acting cylinder. In that first we have seen about the single acting ram type cylinder. Getting it? And in that again we have seen the single acting cylinder with single piston rod. Okay, and with spring loaded. Okay, with a spring. So this type of this type of single acting cylinder we have seen yesterday. Okay, now today we will go for the our further part, that is a double acting cylinder. Okay, that is a double acting cylinder with single piston rod. Okay, double acting cylinder with single piston rod. Getting it? So you can see on the screen whether before going further part, just tell me whether my voice, my video, my PPT, whether it is visible, my PPT and my video, whether it is visible at your end, and whether my voice is audible at your end. Okay, just tell me in chat box. You can write down yes or no.
Yes, sir. All is okay.
Okay. So as like our single acting cylinder. Okay, in the single acting cylinder, we were taking the our fluid or the oil from the port A. Okay, look at on the screen. So in single acting cylinder, I will show you here. Okay, in single acting cylinder we were taking the pressurized oil, okay, inside the cylinder through this port. Okay, okay, and after that in this cylinder, this is a piston is there, and to that piston rod is attached. Getting it? And for a retention of that piston, spring is there, compression spring is used. Getting it? So to get stroke of this power stroke of this piston, we are taking the help of this pressurized oil, that is a hydraulic energy. Now when pressurized oil coming inside this cylinder, no, that time, so what are the pressure of that oil or that fluid upon the area consumed by that pressurized oil inside that cylinder? Through that, due to that, force will be exerted on this surface of the piston. And when force is exerted on this piston surface, then the piston will move in the forward direction. Okay, that means linear motion of the piston will happen. Okay, and then after cutting down that intake of pressurized oil, okay, then after cutting, what will happen? This compression spring will start to retain. That means will start to come to its original position. So to that only it is called retraction. Okay, retraction. First, what are the forward stroke is there? Called extension stroke or extension you can call. And what are the return stroke is there? No, that for that you can call it as a retracting stroke or retraction. So when it is coming towards its original position, that time whatever the fluid is there inside that cylinder, it will come outside through the same port. Okay, through the same port. Okay, in single acting cylinder, the same port is used to take in pressure inside and to take out the fluid outside. Getting it? This is a single acting cylinder with single piston rod. You can see in this image also, single piston is used. Okay, single piston rod, not only piston rod here used is single. Okay, and as per the ISO standard, to represent this single cylinder with a spring loaded, no, here you can see single acting cylinder with spring loaded. So standard symbol is like this. Okay, here one port is there, and this is a cylinder. Okay, this piston, then rod, and this is spring. So this is a standard symbol to represent, to indicate single acting cylinder with spring loaded. Okay, and if you look at the that symbol, through that also you will come to know that single acting single piston rod. Getting it? Now this was about the single acting cylinder. Now come to our main point, double acting cylinder. Okay, again in this double acting cylinder we are going to see the with single piston rod, with a single piston rod. So here I have shown the schematic diagram as well as the symbolic representation of a double acting cylinder with a single piston rod. Getting it? So please just see on the screen. As like single acting cylinder, here also we have the cylinder body. Okay, cylinder body. Okay, now to take fluid or that oil inside that cylinder, we have the port A. Okay, and this is the left dead center, you can call left dead center of the cylinder, here right dead center. Okay, and inside that cylinder we have the piston, you can see. Okay, and this piston is attached with this piston rod. Getting it? And now here also you will have the other that ceilings, a wiper. Okay, everything that as like whatever the I have shown here, no, that cylinder cap, sorry, piston rod wiper. Okay, that sealing part, piston rod guide or the piston seal, piston o-ring, everything will be there for each and every actuator. Okay, here also. Now see, through this port A, fluid will come inside this your cylinder. Okay, so when pressurized fluid is coming inside this cylinder, that time fluid pressure can be exerted on this surface of the piston. And when this pressurized fluid which is came inside that cylinder, it will exert the force on this surface. And when it will exert the force on this surface of the piston, that time your piston will move in the forward direction, in the forward direction. Getting it? In the forward direction. So that time when piston is going to move in the forward direction, in the linear direction, that time your piston rod also move in the forward direction. So due to that only you can check. Here also I have shown the motion, it's a representation. I have shown the arrow, power stroke. Okay, extension happen, that this piston. Okay, at start piston will be there here. Correct? Call I will call this a piston position number 1. And when this fluid is coming inside this cylinder, that time it will exert the force on this piston, then momentum will happen and this piston will move like this up to this position. Okay. So I will call it as a position number 2. Getting it? Now after coming that, after that piston is going to come to this position 2, no, then for that time your port will close. Okay, that means your fluid will cut off. Okay, fluid will cut down that time. Okay, cut down means what, or cut off means what? What are the fluid was coming from the piping, no, that will stop. It is called cut on and cut off, you can call. Okay, on and off, like our light on off. Okay, like that fluid will cut off. Okay, that means it will not come inside your cylinder. So after exerting force to this surface, once again I am repeating, piston will come to the position number 2. Okay, that means your piston rod will move toward this direction. Okay, then now after getting whatever the useful work, now after completion of the useful work, your piston rod will want to, or we want to move this piston rod to its original position. That means this one position. So that time through this port B, another fluid will come inside this cylinder, and that fluid will exert force on the surface of the piston like this. Okay, then that time due to the pressure, due to the force which is exerted by the fluid which is coming from the port B, due to that force your piston will move from position number 2 to the its origin position, that means 1. Okay, and simultaneously that time from the port B, whatever the initially fluid was coming to the that cylinder, no, so that will come outside through this port B. Okay, so this is the called double acting cylinder. Okay, through port A, fluid will come, it will exert the force on the piston, then piston will move. Okay, then after completion of the, or after obtaining the useful work through the port B, another fluid will come, and then it will start the retraction. That means retraction stroke. Okay, that means that piston will come to its original position. Okay, and that time from this port A, your fluid will come outside, and in the next cycle port A will take fluid inside. That time, and when this piston will move in the forward direction, that time to the port B, what is the fluid was there, no, that will come outside. Okay, so like that cycle will complete. Okay, this is a working principle or of a double acting cylinder. Now how to represent this double acting cylinder? Okay, using the standard ISO symbol. So you can check, you can see this ISO standard symbol. See, same as like the single acting cylinder, but here we have to give the 2 ports. This is port number 1, this is port number 2. Okay, single piston rod, single piston rod. Getting it? This is standard symbol. One more diagram I will show for this double acting cylinder. This one, from port A you can take fluid inside, then due to that fluid it will exert force on this piston surface, then this piston rod will move like this in the forward direction. Okay, after completion or after obtaining the useful work through the port B, another fluid will come inside the cylinder, it will exert the force on this surface, then the piston will come to this original position, and that time what are the fluid was taken inside through the port A, it will come outside. Okay, so this is a construction diagram of double acting cylinder with single piston rod. Okay, with a single piston rod, you can draw this diagram, no problem. Okay, whether understood or not, whether understood or not, here the force will exert on the both the side of the your piston area. Okay, due to that only it is called double acting cylinder. Okay, double acting cylinder. So here there are 2 different piston areas on both sides of your piston. Okay, due to that piston rod will move in the forward direction. Okay, and here what are the retraction force is there, the retraction stroke, that means the returning stroke is there, no, that will be the faster than your extension stroke. Okay, because what are the force is there often in the extension stroke, that means in first power stroke, that will more than your retraction stroke. Okay, extension means what? Your power stroke. What are the first forward or momentum will be there? That's called extension stroke or power stroke. And what are the retaining stroke is there? That is also called retraction or retracting stroke. Now, whether you understood, say yes or no in the chat box, so that we'll go for next. Everyone, please tell me, say yes or no in the chat box. Only 2 to 3 students are saying yes, no. Another student. Okay. Now, related to this double acting cylinder, I will show one small animation video, and then I will give 2 minutes to to draw this diagram. Okay. Quickly, I will show video.
In this video, I explain construction, applications, and working of double acting cylinders. So first we
Only small video I will show. What action happens? See, this is a single rod type. Okay, single rod means a piston rod. Okay, whatever we have seen, no, that is a single rod type. Okay, double rod type, yet I have not discussed. We'll see. So first we'll see the video of the single rod once again. Understood? See. Okay, quickly I will show one more. This was a single acting cylinder. I think yesterday we have seen, or not, that I don't know, but quickly I will show that this also. This is a single acting cylinder. The same port will be used for intake and for the outlet purpose. And this is spring loaded. See, that blue portion is the fluid. Then it is a power stroke. Okay. Understood or not? In the chat box, say yes or no. Understood or not? Double acting cylinder. Double acting cylinder. Whether you understood or not. Understood or not? Okay. Now I request all of you take 2 minutes to draw this diagram. Okay, be fast. All of you please draw this diagram as well as symbol of the double acting cylinder with single piston rod. Single piston rod. Then after this we'll go for the double acting cylinder with double piston rod. Okay, with double piston rod. Be fast. What are the, for the symbol, whatever the that dash A and B, sorry, dash, okay, where A and B written is there, no? So that A means what? That is the intake port. Okay, through that you can take first fluid inside the your cylinder, and this is a B also. Both the A as well as B ports are used for the intake and outlet purpose. Okay, and your piston will move in both direction. You can see here arrow also I have shown. Okay, so this is important. Once again I am repeating, in OC exam or in the ISC, 4 marks question will ask for on each point like that. Explain double acting cylinder, okay, with schematic diagram. That time, firstly you have to draw the schematic diagram, okay, and it's a symbol. Then you have to give the explanation. Then and then only you will get the marks. Without diagram, for answer 0 weightage is there. Okay, if your diagram is correct, that means whatever the explanation you have written, that will be correct. Now this double acting cylinder, it is used, okay, for just you can say to move something. Okay, if some product is there and if you want to move in forward direction only, okay, that time this double acting cylinder you can use. Okay, but in certain applications such as for example feeding of machine table in a machine tool. Okay, once again I'm telling feeding of machine table, okay, in machine tools. So that time they demands motion to be transmitted on both the sides. Okay, like that for the simultaneously in the left side also motion should happen, and in right side also, okay, simultaneously. That time we need to have double acting cylinder with double piston rod, with a double piston rod. Whatever the rod here I have shown, no, okay, in this diagram, that rod will be from the for this direction also, okay, from for this direction. That time it is called double acting cylinder with double piston rod, with a double piston rod. That is the only change, okay, or that is you can call modification in this double acting cylinder, okay. Okay, once again I am repeating, in some industries there is a need to feed the your machine table, your machine table in uh, both direction, okay. So that in that application they demand the motion to be transmitted on the both sides of the your cylinder, on the both side of the cylinder. That for that, or in such application, we need a double acting cylinder with double piston rod, okay, with a double piston rod, okay. We'll go for that. So this is a construction or schematic diagram of double acting cylinder with double piston rod, okay, with a double piston, okay. As like this you can see this same diagram is there as like your previous one, but here the piston rod is in the both direction, okay. So here also through this port A you can take fluid inside, and due to that fluid it will exert force on the surface of the, I will highlight that portion, okay. When fluid will come inside through this A port, no, so that time this fluid will exert force on this surface of piston. That time your piston rod will move in the forward direction, okay. Okay, but on the same at the same time your this end of this piston rod, it will come inside, okay. Inside means in the this side, whatever the arrow I have shown. But when fluid will come through this B port, no, that time your this piston rod will move in the this direction, okay. At same time, what are the fluid present in the this side of the cylinder, it will come outside, okay, and this rod will move in this direction, okay. That means simultaneously motion will happen, okay. So due to that only it is called double acting cylinder with double piston rod, okay. Here piston is same but piston rod is double, okay. Simultaneously fluid will take from A, and that when it will piston surface port B, fluid will come outside from this portion of the cylinder, okay, and reverse action will happen, okay. And you can check the symbol also. Two cylinder is there, two ports I have shown here, piston, and the motion of the piston, it is shown by this arrow, and this both the side piston rods are there, okay. So this is a schematic diagram of your double acting cylinder with double piston rod, okay. Please draw this also, okay. Then I will show the another video of this, or wait, I will show immediately. Okay, we'll see the cylinder, hydraulic cylinder with double piston rod. this is your cylinder body. Okay, these are the two ports, and here what are the portion I have given no gap. Through that gap your piston rod will come. You can see. Cylinder, sometime in many industries or in the our commercial application, we need the motion or transmission of motion from the both sides of the cylinder. That time we have to select this type of double acting cylinder with double piston rod. Getting it? This is the application. Now all of you, please draw this diagram. Hurry up. Whatever the diagrams I have inserted in this slide, so all diagrams I have taken from the hydraulics and pneumatic book by Ilyas Khan. Okay, yesterday I have shown that copy. Over. Okay, now let us go for another one. That is now whatever the we have seen the single acting and double acting. That was the types of the linear cylinder, sorry, linear actuator or hydraulic cylinder. Now in that again we have the special types of the hydraulic cylinder. Okay, from that category, firstly we'll go for the tandem cylinder. Okay, so it's a figure I have shown in the slide. So this tandem cylinder, it is a combination of two or more cylinder. Okay, You can see on this slide. Here also I have used 2 cylinders. Okay, so tandem cylinder means what? It's a combination of 2 or more cylinders. Okay, and it is that both cylinders are coupled mechanically to each other. Both the cylinders are coupled mechanically to each other. You can see here one cylinder is there, this one. Here, this is your first cylinder, and this is your second cylinder. Okay, so these 2 cylinders are connected to each other. Okay, mechanically they are coupled to each other. Getting it? So this is called tandem cylinder. Okay, and each cylinder has its own inlet and outlet port. Okay, each cylinder has its own inlet and outlet. You can see for this first cylinder, this is second cylinder I will call. Okay, so for first cylinder, inlet port is A and outlet port is B. Okay, and for second cylinder, port C is your inlet and port D is your outlet. Okay, so for each cylinder it has its own inlet and outlet ports, but that cannot operate independently of each other. Okay, they cannot operate independently. Okay, both the cylinders operate depend on each other. Okay, so advantage of this tensioning this cylinder, it lies in the force addition. Okay, because we are coupled, we have coupled 2 cylinders to each other. That means we will get more force. That means the force addition will happen. That means greater force can be obtained by this tandeming. Okay, tandeming is action, so it's called the tandem cylinder. Okay, we'll get greater force, more force. Okay, that can be obtained at a same pressure. Okay, without increasing the piston size. Okay, but here piston areas, sorry, what are the areas on which pressure is going to act now? So that area is going to will be greater area. Okay, so you can see force will act on the this side. Okay, and this side also. Okay, this surface as well as this. Okay, that time this piston rod will move like in the forward direction, and when the fluid will come through this D port and B port, then force will exert from this side. Okay, that time your piston rod will move in this downward direction, or that retraction action will take place. Okay, getting it? And it's a standard symbol. You can see here we have the cylinder. And for both the cylinder we have the separate piston. You can see, and both the cylinders are coupled each other mechanically. Okay, so this is a standard symbol of tandem cylinder. Okay, now let us, I will show one small video so that you will get you will understood quickly. Tandem cylinder. Okay, as I have mentioned here, 2 or more than 2 cylinders are connected coupled each other. So this type of cylinder you can call combination cylinder also, because two double acting cylinder. I will show. Here double acting cylinder are connected to each other, okay, in series. Okay, in series they are, both the cylinders are connected. And where it is used, wherever we need high force, that time these two cylinders are connect, you can connect each other. You can see it's animation also, how it works. You can see inlet outlet port. Getting it? Very simple. Double acting cylinders are connected to each other. Okay, if it is two or more than two, then that is called combination cylinder or tandem cylinder. Okay, now all of you take 2 minutes to draw this diagram, then we'll go for next one. Hurry up, be fast, please draw this diagram and symbol. Hurry up, be fast, please draw this diagram. Tandem cylinder is not just a combination of two double acting cylinders, two or more than two double acting cylinders. When we want more or greater force, okay, at the same pressure, without increasing pressure piston sizes, but increase the areas on which pressure is going to act. Okay, so that time you can couple two or more than two double acting cylinders. Okay, and these types of the double acting cylinders finds application especially where high force required, okay, with limited space. Okay, high force is required with a limited space. Okay, that time total force you can measure by using the pressure into area of your first cylinder plus pressure into area of the that cylinder 2. Okay, finished. Now let us go for another one. That is telescopic cylinder. Okay, so the telescopic cylinder. So as the name implies, this telescopic cylinder, it works similar to our telescope. We know that telescope. Okay, so this telescopic cylinder, it as name implies, this works similar to our telescope. Okay, which can be extended several times. Okay, our cylinder, it can extend several times of its unextended length. Okay, because we know that our telescope, it looks like very small, but from that you can take another that you can call pipe or whatever the cylinders are there inside that. Like that, here also in the telescopic cylinder, small cylinders are mounted inside the big cylinders, and like that, 1 2 3, like that, other cylinders are mounted inside the one big cylinder. Okay, that is called, here also diagram I have shown. Okay, what are the figure I have shown? That is the diagram of the telescopic cylinder. Okay, and here a series of ramps. Okay, it is arranged telescopically. Okay, so you can see this. Okay, this big cylinder, it is called A cylinder. You can see. Okay, this A. So this A means what? Diameter of cylinder A. Diameter A is the relatively, this is a large than this diameter of B. Okay, this is second. A means you can call A is the diameter of this cylinder. So you can call this cylinder A. Inside that, B is mounted, and that means diameter of A is larger than the B. Then inside this B, you can take cylinder C. Getting it? That means diameter B is greater than the C. Okay, hence during extension, when you will take fluid inside from this fluid supply for rising, no, you can see here port I have shown. So from this port you can take fluid inside. Okay, at this portion, that means A. So that time it will apply force on this surface, and simultaneously some part of the fluid will come inside this B cylinder. That time it will apply force, exert force on this surface, and simultaneously some fluid will come inside this C, and that time it will apply or exert some pressure, force on this C piston also, C portion of this C cylinder, and due to that only the force. Okay, due to the total force, this ram or this piston, whatever the rod is there, it will move or it will lift. Okay, in the upward direction. Okay, so this will happen. Now after lifting upward direction, your useful work will, you will get useful work. And when, if you want to take down, that time your fluid will come outside through this C port here, whatever I have shown, then from B, and it will, you can take outside from this fluid supply for lowering port. Okay, so this type of telescopic cylinder you might have seen in the dumper or tipper, whatever I have shown here diagram. You can see whatever our dumper is there, or the tippers. Okay, what we have seen, everybody have seen. So that cylinder, what I use, no, you can see here also, that is called telescopic cylinder. Okay, at initial stage, uh, it looks like there is only one cylinder, but when that lifting action will start, that time another cylinder will come outside from the that first one. Then again lifting action will go for higher range, then another cylinder will that small cylinder will come outside from that first cylinder. Okay, so that will extend. Okay, that is called the extension or that power stroke. Okay, and then your what are the work you want to take down that mud or whatever the your sand from the dumper, this no you can take. And after completion of that useful work, to take down this, you need to take out this fluid also. That for that only here fluid supply for lowering, that means to lower the all the cylinders, no. Okay, we need to take fluid inside. Okay, so for that here another port is given. Okay, so here also it will apply force from in upward from this upward direction. Okay, then it will comes down down down. Okay, and as per the ISO standard, the symbol or for to represent this telescopic cylinder, the symbol is like this. Okay, you can see big cylinder is there. Okay, for rising, that for means for lifting we need to take inside fluid, so that to for rising fluid supply it is represented by R, and fluid supply for lowering it is represented by L. Lowering means what? For retraction force stroke. Okay, and inside this port big cylinder another cylinder is there. This one, this is one, this is two. Okay, this is sorry, this is two, then this is three. Okay, this is standard symbol of the telescopic cylinder. Okay, now I will show small video, then we'll go for the it's a diagram. Okay, I will show cylinder. See this animation. When fluid will come inside the cylinder, it will move in upward direction. When fluid will come for lowering, it will go inside the cylinder. Getting it?
In this video, I explained the other types of linear actuators.
Okay. Understood or not? All of you tell me whether you understood or not. Here also here I have shown another diagram of telescopic cylinder. You can take pressurized oil inside, okay, for rising. Here also I have shown the ram 1, ram 2, ram this 3, okay, and in dumper for lifting the bucket, telescopic hydraulic cylinder is used, okay, dumper tipper. Now you can please draw this diagram. Okay, don't draw the diagram the tipper, just this one, okay, and then it's a symbol, standard symbol. You should know all the standard symbols. It is very easy. It is similar to, or it is relative to your diagram, okay, construction diagram, schematic diagram. So be fast. I will give you 5 minutes to draw this because this diagram is somewhat large. Whether you understood or not, in the chat box say yes or no. Understood? Okay, I will ask one by one. Simultaneously, all of you please draw the diagram. राकेश बिराजदार, रोहित कदम, राहुल कडके, सुहास नसते, पूजा कापरे, अजित गायकवाड, सोन टक्के, शनेश्वर मिसाळ, गौरव कंडळकर, अजित, सचिन सुतार, प्रथमेश पाटील, शेंडे, ज्ञानेश्वर, शुभम सिंगन, शुभम, another roll number 2, Dikshad Mile, understood or not? Then Shivani, Balaji Pise, then Nikita Pawar, Suyok Jadhav, understood or not? Just tell me in chat box, understood or not? Okay, now hurry up, please draw this diagram. Okay, for ISC 1, what are the syllabus I will cover up to Sunday, that syllabus will be there for the ISC 1. Okay, so what are the cylinders today we have seen? Out of these 3 cylinder, double acting, telescopic, tandem, out of these 3, fixed one question will be there for 6 mark. What are the yesterday we have seen? Out of that also one types of the cylinder, that question may I will ask. Okay, then application of the fluid power. Okay, and the one thing I want to clear here itself, why I am giving more weightage for this all topic of the hydraulics, because once all the topic, once all concepts of the hydraulic will be clear, no, then same concepts are applicable to your pneumatic part. Okay, whatever actuators we are going to see here, same actuators are there in the pneumatic part also. Only the change is your fluid here. Instead of here we are using the pressurized oil, but in pneumatic compressed oil, compressed air will be there. Okay, Same. What are the pumps we are going to see in the hydraulics? Same pumps we are going to see in the motors. We are going to see in the pneumatic part. Okay. Then what are the that cylinders? That same cylinders will be there for pneumatic part also. Same syllabus is there. Okay. Only change is the fluid. Okay. Due to that only, I am trying to clear your all concept here itself. Okay. If all the points will be clear here, that then during the pneumatic section, that is the chapter section number 2, that time it will be easy to understand the all the point concept about that pneumatic. Okay, because that time you will tell you will say that same point is there, sir, whatever we have seen in the hydraulic same. Okay, due to that only I have given more weightage for the hydraulics. Okay. Okay, so all of you, please complete this diagram and simultaneously please write down your roll number in the chat box as your attendance. After completion of your diagram and after writing your attendance, you can leave this lecture, no problem. Okay, see you tomorrow, but you have to draw this diagram also. Be fast. Okay, tomorrow we'll see some another hydraulic cylinders, and then we'll go for the that cushioning effect and all this thing. Be fast. All of you, please draw this diagram and write your roll number in the chat box. Okay, then only you will be allowed to leave this class or leave this meeting. Okay, if you have completed, if you have written your roll number, then you can leave this meeting, no problem. I will give 2 minutes more. Be fast. Balaji Pise, Sontake,